Welcome back, everyone. We're going to be solving LeetCode 286, walls and gates. So we're given an n by n grid called rooms, initialized with three possible values: -1 for a wall or an obstacle, 0 for a gate, and infinity for an empty room. We need to fill each empty room with the distance to its nearest gate. If it's impossible to reach a gate, we should fill it with infinity. So we are going to use breadth first search to solve this, and what we'll do is we'll initially loop through our grid. We will find all of the gate positions and add those positions into an array which will be used for holding the gates for further processing. After we have those positions, we will then run breadth first search on each of those positions and just update each empty cell accordingly. So again, breadth first search, so we will implement our deck from collections. First thing we need to do is create an array. We will call it toProcess, and we will loop through our grid. So we'll say for row in range length of our grid, and for column in range length of our grid at row 0. Okay, once we've done that, what are we going to do? We're going to check if grid at the current row and the current column, if that is equal to a 0, it means it is a gate. So what do we want to do? We want to append that gate onto our processing array, but we don't just want to append the row and column. We're also going to want to give it an initial distance value of 0. So we will say toProcess.append the row, column, and an initial distance of 0. So let's print out our toProcess array so we can see what we're working with. And as we can see, we have a gate at row 0, column 2, which is this one right here, and we gave it an initial distance of 0. So when we run our breadth first search from this gate, this cell will have a distance of 1. This one will have a distance of 1, right? Just like it has in the picture. And we have another gate at row 3, column 0, which would be this one right here, and an initial distance of 0. So now that we have our gates inside of an array, now we just have to run breadth first search. So we'll say for gate in toProcess, what are we going to do? We are going to run breadth first search. So we will say q.append that gate. Actually, we have to initialize a q first. So we'll say q is going to be equal to a dq with our gate on it. And we are also going to have a visited set to hold all of the grid positions that we have visited already. Alright, now we can run our breadth first search. So we'll say while the length of our queue is not equal to 0, what are we going to do? We are going to pop off the row, column, and the distance from our queue. Q.popLeft. Now, what do we have to check? We have to check and make sure that the current position we are at, and make sure it is not a gate and not an obstacle. So we will say if grid of row, column, if that is not equal to a gate, and grid of row, column is not equal to an obstacle, what do we want to do? We want to check and see if we can potentially update the distance. How can we do that? We will say if grid of row, column, if the distance value is less than the current value at that row column position, right? Because if it's an empty cell, it's filled with infinity. So if distance is less than that, we are just going to update the grid of the row column position to be equal to the distance. Now, once we've done that, we still have to check all of the other cells within our grid from that point, right? So how can we do that? We need the next row down, the previous row before whatever cell we're at, and then we also need the right and left columns. So we will have to check, all right, well, if our row plus 1, right? If that is greater than or equal to 0 and less than the length of the grid, that means we have a valid position within our grid for the row, and we will have to do the same for the columns. So if the column is greater than or equal to 0 and less than the length of our grid at the first row, so if this is true, we also have to do something else. We'll also have to check and make sure that, okay, well, is the position of the next row, current column, is that invisited or not? We want to make sure it's not invisited. And we want to make sure the grid at the next row of the current column is not equal to a gate, and the grid at the next row current column is not equal to a wall or obstacle, right? If this all passes, we're going to do something. What are we going to do? We are going to add the next row current column to our visited set, and we will add the next row current column and increase the distance by 1 to our queue so we can process the next one. So if we're at this gate, this first gate of 0, 2, that means this cell right here would be 1, right? We would append this cell onto our queue and then go through the processing. And we would hit this and we would turn this cell's distance to 1. Right? Now we have to do the same thing for the other 3 directions. So instead of going to the next row, we want to check the previous row. So instead of r plus 1, we will have r minus 1 everywhere here. Minus 1, minus 1, minus 1. Now we need to check the next column. So anywhere you see r plus 1, we can get rid of that. R plus 1, r plus 1, and r plus 1. Now we need to check the next column. So let's hit this one, this one, this one, here, here, and here. I'll change that to plus 1. Now we need to check the previous column. So let's change all of this to minus 1. Minus 1, minus 1, and minus 1. Okay, so now we are not returning anything because we are doing this in place. So we should be good to go. Let's run this. Invalid syntax. What did I do here? R plus 1 is less than the grid, and right here, column should be less than the length of our grid. Alright, so let's rerun this. Again, I probably did that everywhere too, didn't I? Yep, I did. Plus 1, okay, now we should be good. Awesome, perfect. So we passed both test cases. So let's submit this. Awesome, and it does run. So time and space complexity for this. Time complexity is going to be O of m times n, where we are processing every cell within our grid, and the space complexity is going to be the same. We have to have every cell in our grid onto our queue, right? All right, that'll do it for LeetCode 286.